Types of operating system. Batch processing. When computing was still a new science, there were not enough machines to satisfy the demand for processor time from students in universities who wanted great calculations done, firms who wanted their payroll worked out, and many others. The big problem was the speed mismatch between the user sitting at the keyboard who was very slow, and the machine which was very fast. This meant that the expensive part, the computer, was sitting there doing nothing while the human being decided what to do. There are two simple solutions to this problem. One is to buy more machines and the other is to make the machines work more effectively by taking away the slowest part of the system, the human being. Nowadays we might well opt to buy more machines, but this used not to be an option. This problem gave rise to the development of batch processing. A batch processing operating system is one that does not allow for interaction between the user and the processor during the execution of the work. Lots of programs or data that need to be run are collected together to form a batch, and they are sent to the computer. The batch operating system then controls their passage through the computer. Nowadays, batch processing tends to be used where there are large amounts of data to be processed. The data is very similar in nature and it requires similar processing. The computer system has identifiable times when it is not being used, and so has available processor time. The application does not require human intervention. Typical examples of applications which would be done using batch processing include production of bank statements from customer files, production of gas, electricity, telephone, bills from customer records, the compilation of high-level language programs where a number of users want programs compiled. Real-time. A real-time OS is one which can react quickly enough to affect the next input or process to be carried out. Most real-time systems are based on control of some process in the real world or on information handling. A chemical plant has a reaction vessel where the temperature is critical to the result of the process. The temperature is monitored by a computer which accepts input from a sensor and then makes a decision whether to adjust the heating elements in the vessel. In this example, it would not be sensible for the computer to be running any OS that is not real-time because if there was a delay in the decision-making process, it might mean that the reaction is corrupted in some way. A robot trolley is controlled by a processor which takes input from a sensor following a black line on the floor, and makes decisions concerning steering to keep the trolley on the black line. If the processor was not controlled by a real-time OS, the trolley would very soon leave the black line because it would not be steering quickly enough. A catalog shop processes orders by the code for a product being input and the system then comparing the code with information in its files. When it finds the correct code, it can report to the user the number of that item that there are in the store. If there was only one left of a certain item, it would be necessary to record the fact that a shopper had bought it before the next shopper has their request dealt with, otherwise the second person might be sold the same item. Because the information on the system must be processed immediately, the OS needs to be ready to handle input as soon as it comes in. This means that it cannot be using up some of its slack time doing other tasks while it is waiting to be asked to do something. This implies that the computer will not be using its full potential as far as processing is concerned. When this happens, it is said to display a high rate of redundancy. Real-time systems tend to display a high rate of redundancy.